Hello and welcome to this session in which we'll discuss the IT architecture and its component. IT architecture is crucial for organizing and utilizing technology resources to do what? Why do technology resources exist for a company? To serve the business objective and the business need of that business. So in this session, we're going to be looking at some basic infrastructure of IT architecture. What are those key components that you need to know whether you are an accounting student, a CPA candidate, or an accounting professional? You need to be familiar with this modern architecture of IT, information technology. One is operating system. Two, servers, network infrastructure, end user devices, storage, middleware, software applications, and data architecture. You need to be familiar with those 8 components, and this is what we will discuss in this session. Now, in this session, I'm going to look at each of these components, define it, tell you what's the purpose of it, what's the main purpose, give you a few examples from the real world. Eventually, each one of these topics, just kind of give you an idea, will be covered a little bit more in depth. For example, storage, which is part of data, will be covered a little bit in depth. Network will be covered a little bit in depth. So on and so forth, software applications, as well as other systems, servers, so on and so forth. Let's go ahead and get started by looking at operating system. Before we proceed any further, I have a public announcement about my company, FarhatLectures.com. Farhat Accounting Lectures is a supplemental educational tool that's going to help you with your CPA exam preparation as well as your accounting courses. My CPA material is aligned with your CPA review course such as Becker, Roger, Wiley, Gleam, Miles. My accounting courses are aligned with your accounting courses broken down by chapter and topics. My resources consist of lectures, multiple choice questions, true-false questions, as well as exercises. Go ahead, start your free trial today. The operating system is the brain of the computer. It's the system that manages computer hardware, software resources, and provide services for computer program. It's the brain. Without an operating system, you cannot function. It's an intermediary between users and the computer hardware. Without the software system, operating software system basically will have chaos. So the purpose of it is to manage hardware resources. How to control and manage hardware such as the central processing unit, memory, storage devices, input-output devices, basically everything. Allocate resources and ensure efficient execution of tasks. It also provides services to software, hardware, as well as software as well. It offers services and libraries that are required for the development and execution of software application. The system would help execute the software application that you have. It handles errors and manages interaction between software and hardware. Once again, think of it as the brain. It enables users interaction, offers user interaction either graphically or command line. Basically, the command line are gone. Most of the time, operating systems are graphical in nature, allowing users to interact with computers. When I started to learn about operating system, we used to have something called DOS, and it's basically command. You have to write the command. Now you can point, click, so on and so forth for the operating system. It manages user input and output, translating actions into machine-level instructions. What are types of operating system in the real world? We have desktop operating system, and here we're looking at Windows and Linux. Now in this session, I'm going to be mentioning many names and many terms. Oftentimes, I don't know exactly every single term or name. For example, I may name a technology. It doesn't mean I'm familiar with it. The reason I name it and I list it as part of the explanation is you might know what it is and you might be able to relate. So you may not know what Windows, but you might know what Linux, or you may not know what Linux, but you may not know what Windows or Mac operating system, but you will know one of them. For example, Windows, Mac operating system, and Linux are desktop operating system, primarily used on personal computers, laptop, and workstations. We have mobile operating system. Can you think of mobile operating system without me showing you the answers? I hope you do. iOS, which is Apple, and Android, which is Google. Those are developed for mobile devices like smartphones and tablet. You have servers operating system. Here we're looking at Windows servers, Ubinet server, another type of server software. It's designed to run on servers and provide services to network computers. We also have embedded operating system, and here we're looking at something called FreeRTOS or embedded Linux. Those are tailored for embedded system like appliances, industrial machine, and automobile. So you might see them in your microwave. You might find them in your microwave. You might find them in your washing machine. And we have real-time operating system, RTOS, such as QNX and VxWorks, and those are used, for example, for aircraft navigation, or medical devices where they give you real-time information, or in robotics. Going from operating systems to servers. What is a server? A server is a software application or hardware device designed to perform specific tasks or set of tasks that respond to requests across a computer system. The main purpose of a server, when you think of a server, is a host. Host and manage application, services, and databases. It's a place where things are located. It stores processes, and manages access to information, application, and services. It acts as a centralized location where services are hosted and data is stored and retrieved. It's basically where you store stuff. Host, it's a server. So we have, it serves clients' requests and manages network resources. For example, it handles requests from clients and service responses, allowing multiple clients to interact with the same application or database. For example, when you have a website, the website is hosted on a server. So you have people coming from the website. So this is the website, it's hosted on the server, and you have people trying to access the website all at the same time. The server would allow you to do that. It manages network resources and allocate them to different clients as required. We have many types of services in the real world. I just mentioned one of them. Web servers host web pages to users. Here we're looking at HTTP server, Microsoft Internet Information Services. We have database servers. What do? Provide database services and respond to database queries from client machine. Here we're talking about MySQL, which you have to learn about MySQL a little bit for the CPA exam. Microsoft SQL Server, Oracle Database. You have application servers. Obviously, they do what? Host and run software applications like Apache, Tomcat, JBoss, IBM, WebSphere, so on and so forth. File servers, well, guess what they host? They manage and provide access to, you name it, files within an internal network. Here we're talking about window file servers. We have different types of servers. We have mail servers as well. What do? What do they host? Manage and transfer email over a network, like Microsoft Exchange Server. Most likely you're using it as your mailing or email service. DNS servers. Purpose resolve domain names to IP addresses. Basically, determine whether this IP address is legitimate or not, like Microsoft DNS. We have proxy servers. These act as intermediaries between end users and the website they visit, providing security, anonymity, and content filtering. For example, on the proxy servers, you can limit certain websites, certain access to certain pages. Examples will be Squid or Apache traffic servers. Moving from servers to network infrastructure. Networking. And we're going to talk more about networking. It refers to hardware and software resources of the entire network that does what? That enable network connectivity, networking connectivity, communication, operation, and management of an enterprise. The purpose is to do what? It's communication, provide connectivity and communication. The network infrastructure is what connect different things. You see, those lines are connecting the servers to the computers, to the cloud, to the end user's laptop, desktop, tablet, so on and so forth. It enables the interconnection of computers and other devices to share resources and information. It facilitates communication between users, systems, application, and external network and internet. And because of that, it ensures data integrity, availability, and most importantly, security, because it connects everything. You want to make sure the data that I'm accessing, it's the same that someone else is accessing. It's available, and it's most importantly secure. It protects the data from unauthorized access and data corruption throughout its life cycle. It ensures that the network services are available when needed. So what are the components, the pieces of a network infrastructure? Most likely you have one right in front of you where you are sitting right now and listening to this recording. If you're using a desktop, you might have a router at your home. It's direct. Purpose of the router, it direct packets between network and connect different network segments. Now you might only have one, but in a business you will have several ones. For example, Cisco router, or the router that's close to you, that's sitting close to you right now. We have switches, connect devices within a network, look something like this, within a network segment, and use MAC addresses to forward data to the correct destination. Gets you there. Cisco switches, Netgear switches, so on and so forth. Firewalls, that's an important part of network, and we'll talk about firewall in a separate recording more in depth. Protect networks from unauthorized access and cyber threat by controlling incoming and outgoing traffic. It filters the traffic, and we'll talk about the firewalls later on. All what I'm doing here is giving you an overview of the IT infrastructure, and all of those are part of what? Components of the network. Examples will be Palo Alto network firewalls, Fortinet, FortiGate, so on and so forth. Access points, it's where the connectivity is provided, provide wireless connectivity to a wired network. It's the point where the information is there. Aruba access point, we have Cisco, Aeronet access point as well. Other components of the network, it's a lot of components, cabling and connectors, physical cables. Purpose, facilitate the connection of different network device and the transition of data. Here, you need cables, you need connectors, physical one, Ethernet cable, fiber optic cable, so on and so forth. You have network interface card, they're called NICs. Provide the interface for computers and other devices to connect to a network. NICs, example will be Internet, Ethernet, and most likely, if you work for a large company, you might have them. Otherwise, most of the networking now is basically Wi-Fi. We have load balancers as part of the network. The purpose of these is to distribute incoming traffic across multiple servers, so no single server is overwhelmed. So when you have request to your system, those load balancers, they spread this request over several networks. Example of them, F5 Big IP, Citrix ADC. Proxy servers, what do? They act as an intermediary for requests from clients seeking resources from other servers. Examples will be Squid Proxy. And we have DNS servers. They translate domain name to IP addresses. Just basically, it tells you when someone places a request, they know exactly where it's coming from. It translates the domain name into a specific address. Moving from servers to end user devices, and end user devices, those are the easiest for you to relate to, because right now you are using a user device, end user device, as you are listening to me, whether you are using your tablet, your cell phone, your laptop, your desktop. Those are all end user devices. End user devices refer to computing devices used by end users to interact with the organization IT environment. Now you're interacting with my environment, with my system. The purpose is to do what? Enable users to access and interact. Provide users with access, interface to applications, services, and network resources. You need something in your hand. Serve as the user interface with IT systems, allowing users to create, modify, and consume content. What are you doing now? You are consuming content. You are the end users, and enhancement mobility and flexibility. You could move around. You can take your tablet, you can take it to Starbucks, you can take it to the local gym and listen to me at the same time, or to your college. Enable users to perform tasks and access resources from different locations, facilitating remote work and mobile access. Examples and types of user end devices: desktop computers. There's a wide range. It could perform wide range of tasks from document editing to software development. But desktop are stationary environment. They don't move. Here we're talking about the iMac, Dell, HP, so on and so forth, desktop. Then we can move to laptop. The difference between them, it's portable. It moves around. They offer mobility and are suitable for a wide range of tasks. Basically the same thing as a desktop these days. We're looking at MacBook Pro, Lenovo. Again, you might be thinking, oh my God, I'm using these. Yes, you are, most likely. Then you could have tablets. That's another user end device. Highly portable devices suitable for content consumption, note-taking, and other lightweight tasks. We're looking at iPad, Galaxy Tab, Surface Pro. For example, I'm using the Surface Pro right now, and you could be consuming the information on the Surface Pro as well. Other examples and types, we could have smartphones. We could be listening to me to a smartphone. It's a handheld device offering a range of functionalities, including voice communication, internet access, so on and so forth. iPhone, Google Pixel, Samsung Galaxy. We have something called thin clients. Basically, those are lightweight computers that depend primarily on the central server for processing activities. For example, my wife, she has a thin clients. Basically, she carries it. It's very thin. She can sit anywhere at the house, at her office, at work, and she have access to everything. They're called thin client. Dell Wise, HP T360, and we have the wearables. Wearables, the devices worn on the body that offer functionalities like fitness tracking and health monitoring, or the Apple Watch. I'm soon here. We're going to be able to do some work on the Apple Watch, Fitbit, Garmin, so on and so forth. Moving from user-end devices to cloud computing. Again, we're going to look much more at cloud computing later on. We need to learn about cloud computing, but this is an introduction. It's a technology that allows users to access computing resources like servers, storage, databases, network, software analytics. Everything that we learn about can be in the cloud over the internet. That's what the cloud is. It means you can access it. Instead, relying on owning and maintaining a physical hardware, you can basically rent what you need, your computing power, your operating system through the cloud system. So the purpose, we talked a little bit about it, resource utilization and elasticity. It allows organization to use resources as needed. I'm just gonna get what I need, and if I need to, I can scale up, or if I need less, I can scale down. So I can downsize, or upsize based on my demand, based on my need, thus avoiding putting upfront cost and thus reducing waste. So I don't have to invest millions of dollars in infrastructure. I would rent it, and if I need more, I would rent more. If I need less, I will cancel some of these services. It gives you accessibility and flexibility. It provides access to resources and services from anywhere with an internet connection, and I love it. I can be working at the house. I can just stop working, go to my office, open my computer, and keep working. How can I do that? Because my document is in the cloud. For example, if I use Google Doc, or if I use Microsoft Service, they give me that flexibility, facilitating remote work and collaboration. And it gives you access to data management and analytics. It offers powerful tools for storing. I love it because every time my computer dies, my Surface Pro, which is 2 of them died already over the years, I don't care. Why? Because all my files are in the cloud. Once I buy a new one, I start the computer, I log into my Google Drive or OneDrive, boom, I have everything. Processing and analyzing large volume of data. There are several models for cloud computing. We have infrastructure as a service, which is IaaS, and we'll talk about those later much more in details. Provide virtualized computing resource over the internet, like Amazon or Microsoft Azure, so on and so forth. Basically, like Google Computing, basically you are renting your infrastructure. So infrastructure as a service. You could also have a platform as a service. PaaS offer a platform allowing customers to develop, run, and manage application without dealing with the infrastructure. Again, Microsoft Azure App Services is a good example, and Google App Engine. Software as a service, and most likely you are using software as a service without even knowing. Deliver software application over the internet, eliminating the need to install and run application on individual computers, like Microsoft 365. I no longer, back in the old days, 15 to 20 years ago, every time you needed to download Microsoft, you needed CD-ROM. You would input the CD-ROM into your computer and you will download the files. You download the program. Well, that's no longer the case. Why? Because now you can access Microsoft 365 virtually. This is a software as a service, or Google Workspace. Function as a service. Those are platform for building and running event-driven function in the cloud, enabling developers to execute and scale individual function without provisioning services. Here we're talking about, again, Azure functions and Google Cloud Functions. There are several deployments for the cloud. We could have public cloud. What's public cloud? Owned and operated by a third-party cloud service, providing available to the public. So public cloud, anyone can store their information there. For example, I have some of my information stored at Google Cloud, some of it at Microsoft. And you and many other people have the same thing on those services. It's a public cloud. In a separate recording, we'll talk about the pros and the cons. Just know what a public cloud is. You could have a private cloud that's only yours, exclusively used by a single organization, and can be located on premise or hosted by a third party. Better to be hosted on a third party, because the purpose of the cloud is to have security. You want it to be away from your place in case something happened. You could have also a hybrid cloud. Well, hybrid combine both public and private, allowing data and application to be shared between them, provide greater flexibility and optimization of existing infrastructure. AWS Outpost is an example of that. Then we have something called middleware. Middleware is a type of software that acts as a bridge between operating system and the application running on it, or between different applications. Basically, it's in the middle. Middleware. It connects things. Middleware. It facilitates communication, allow different software components to communicate and interact, enabling the integration of different and potentially heterogeneous systems. Although they may not communicate with each other, the middleware will allow them to do so. It enhances functionality. It provides a set of common service and capabilities to application outside of what's offered by the operating system itself, enabling developers to focus on specific purpose of their application without having to deal with the details of network, database, input, output to connect. The middleware will connect all of those for you. It also enables what we call interoperability. It's basically the system standardized the way different system and application interact. So it allowed them to work together. That's basically what it is. Notice it's in the middle. It allowed different things to work together. You can work on different platform or written in different programming language. It will communicate between all of these. Examples and type are message-oriented middleware. MOM supports the exchange of general purpose messages in a distributed application setup. And here we're talking about IBM MQ, Apache, Kafka. Those are examples of it. Object request brokers, that's very common. It enables objects to send requests and receive responses even across different systems. So if you have different systems, in many companies, what happens in many companies, one company buys another company, then they buy a third one, a fourth one, and each one will have a different system. The ORB, object request broker, would help them to do what? To help all these systems communicate. Corba is one of these object requested brokers. Database middleware, here we're allowing different databases to communicate together, provides application with a consistent interface to communicate with different types of databases. Same concept. A company could have many different databases. Why? Because they acquired other companies. Well, then you need a database middleware that allow all of them to communicate. Then you have remote procedure call middleware, RPCs, enable procedure to execute in another address space, commonly on another physical computer. Here we're talking about gRPC, XML, so on and so forth. Just know that the middleware allows different systems, different interfaces, different databases to communicate and work seamlessly. That's great. That's an excellent thing. We have web middleware, again here facilitating the development of web applications, handling requests and responses between the users and the server. We have content management middleware, manages and organizes digital content for website or application. Here we're talking about WordPress, for example, it's a content management middleware. We also have identity middleware, manages and authenticate users' identities, granting permission and securing access. Now, do you need to know every one of them? Not really, but know what the overall idea of middleware, and for example, ORB is an important one. Software application. Well, we should all be familiar with software application. It's a program or a group of programs designed to perform specific tasks for end users or another application. It sits atop system software and operating system and utilizes these foundational technologies to execute its functionality. Can you think of a software application? I hope you can. The purpose is to task execution. Application enable users to perform specific tasks, ranging from simple text editing, Word document, to complex data analysis, game playing, and more. Data manipulation and analysis allows users to input, manipulate, and analyze data to generate information. Well, does Excel sounds familiar to you? It helps you perform automation tasks. Well, can automate repetitive tasks, streamlining process and improving productivity and accuracy. It has interaction features. It provides interfaces for users to interact with and manages data and perform application. Examples, come on, we should all know what software applications are. We have productivity software. The purpose is to produce information. Microsoft Office Suite, this is what I'm thinking about. Hopefully this is what you are talking about. And Google Workspace. We also have web browsers application. Can you think of any? Chrome, Edge, allows user to access, receive, and view information on the internet. Mozilla, Firefox. We have media players. Can you think of some names of media players? I hope so. Media here means audio and video. Windows Media Player, VLC Media Player, Spotify. Games. We could have games. Can you think of any? Provide entertainment through interactive multimedia. Fortnite, Minecraft. Those are application, but they are gaming, software gaming application. We also have communication. We have communication software. We have development tools. Assist developers in creating, debugging, and maintaining other application and services like Visual Studio. We would have communication software. Here we're talking about Zoom. Hopefully we're all familiar with Zoom. Enable users to communicate and collaborate through various means such as text, voice, and video. We have, what else do we have? What other application? We have database software. What do they use? What do they use? They're used to manage and structure data. Data software. Software for databases. MSQL is an example. Data architect. What's data architect? Refer to policies, rules, standards, and models that govern the type, nature, and storage of data within an organization system. This is the architect, the overall map. It's a subset of the IT architecture, focusing on the way an organization's data is stored, managed, processed, and utilized. This is like basically the map. The purpose of having data architecture is organizational alignment. You want to organize, know how everything is organized. Why? Well, data architecture ensures that data management and policies are aligned with your objective and strategies. Your data has a quality and consistency by establishing standards and maintaining the quality, integrity, and consistency of the data across the organization. It also optimizes data flow. What does that mean? It optimizes the data flow through the system and ensures that the effective integration and communication of data between disparate systems. So you have different systems. The data architect, the map, will have to connect all of these together, optimizing the data flow. It allows flexibility and scalability. What does that mean? It means as you grow, you can scale your data management in an efficient way, ensuring optimal performance even as the data volume grows. Because when you create this architect, you make room for growth. So scaling is always a good problem when you grow, but you want to make sure your data architecture allows you to grow without any issues. And obviously you want to make sure within your data architecture you have data security. By defining rules and policies, it helps secure the data and ensuring compliance with relevant laws and regulations. Sometimes you might have to do that. For example, if you are in the health industry, you have to comply with HIPAA. You have no choice. Within your data architect, you have to have this data security and compliance. What are the components of data architecture? You could have data models, represent the organizational data, detailing how data is stored, accessed, and managed, basically a map. You could have data warehouses, basically where the data is stored, central repositories of integrated data from one or more disparate sources used for reporting and data analysis. Obviously, you could have databases as part of your data infrastructure, structured collection of data that can be easily accessed, managed, and update. Again, here we're talking about MySQL. And we can have, what else? We can have data for data architect. We could have big data technologies. We could have ETL processes, which is extract, transform, load, and process. And we'll have a whole lesson about this. Are used for copying data from one source into a destination system. This is part of your data architect. Big data technologies handle the processing and analysis of large databases that are too complex for traditional. We could have big data technologies, whatever that is. That's changing as we speak, most likely. We're talking about Apache or Apache Spark. Data lakes, that could be part of your data architecture, which are storage repository that can hold vast amount of raw data in its native format until it's needed. Basically, put the data there, part of our data infrastructure. Let's take a look at a multiple choice questions from Farhat lectures that's going to help us basically test our knowledge about IT infrastructure. A new startup company specializing in app development is setting up its IT infrastructure. The company needs to decide on an operating system to use for its server. Which of the following operating system is typically used for servers in a business environment? Well, let's kind of eliminate the easy ones. What do I mean eliminate the easy ones? Something that you are familiar with, let's get it out of the way. Is it Chrome? I hope we all know that's not an operating system. That's a web application. Chrome is what? It's an internet browser. Okay, it's Google internet browser. Therefore, it's not an operating system to use. Okay, iOS, it's the Apple mobile device system. Well, that's not what we need. That's not what we need. It doesn't say anything about Apple. So we're between Android and Windows servers. And let's look at what? Let's look at Android. Is it Android? What's Android? Hopefully we all know what Android. It's the operating system for what? For Google. Basically the competitor of iOS. So B and C, once you eliminate B, you should be able to eliminate C, and D is an easy elimination. So what we're left with is Windows servers. Windows servers designed specifically for server environment. I mean, it's kind of basically its operating system for its servers, Windows servers, but you have to know it. I mean, this is kind of easy answer, but you want to know what the other three are as well. Okay, so a Windows server, it's designed to be widely used in business setting because it's secure, it's scalable. Windows server is what you are looking for, Windows server. Therefore, the answer is A. What should you do? Go to Farhat Lectures, look at additional MCQs that's going to test your knowledge. And in this session, it's basically term-based. And this is tested on the CPA exam. Fortunately, luckily, because most of what we covered, I would say most of what we covered, 60% of what we covered today is something you already know. Okay, I would say 20% kind of you know, and maybe 20% may be new information to you. Maybe some of you're already familiar with it if you're a little bit IT savvy, 100%. But I would say 60%. For example, software application, operating system, end users. You know all of that, even networking. So you know most of the information in this session. It's an introductory session. Nevertheless, we need to be familiar with all of it as future CPAs, as future accountant, as future professionals. This is IT infrastructure. You're dealing with it, whether you are working in a small, large, medium-sized company or working for yourself. Invest in your CPA exam. The CPA exam is worth it. It's a 20 to 30 to 40 years investment in your life. Good luck, study hard, and of course, stay safe.